Hello, welcome back. And here is another further maths exam question on matrices. Um, a system of three equations is defined by such where k is a positive constant. Given that there is no unique solution to all three equations, A show that k is equal to 2 for 2 marks. So that's where we're going to start. So let's do the math. So first of all, we need to get our matrix together. So we've got k3 and minus 1 because k times x, that gives us k, and 3 times y, 3, and minus z, minus 1. So there's your x, y, and z. And so it's a matrix with no unique solution. So then the next one will be 3 minus 1 and 1. And the next one is minus 16x, so that's minus 16, minus ky, so we've got minus k, and minus kz, so we've got minus k again. So, and of course, they're equal to that's all going to be really equal to 0 because we must have a determinant of 0 for that. So now, what do we have to do? Well, we have to that's k times minus 1 minus k times minus 1 minus k. So we end up with k and then k plus k. And we subtract minus 3 is next, and that will be times by minus 3k, and then plus minus 16, so plus 16. And then that will be plus added to, and then minus 1, minus 3k minus 16. So minus 1, minus 1, minus 3k, and I've run out of space there, minus 16. So let's just put it underneath so that there's no confusion, hopefully. Apologies for that, should have given more space there, written it underneath. So that's plus, I put plus, and then it's minus 1 times minus 3k, what do we say, and minus 16. And yeah, that's the first thing that we need to do. And now, of course, we're going to expand that out. So that leads to, we have 2k squared plus k squared. That gives me k plus k. So that gives us 2k squared plus 9k. So that gives us 2k squared plus 9k, yeah, minus 48, plus 3k plus 16, plus 3k plus 16, and we've got to put that equal to 0, because our determinant must be 0. And we tidy up. That gives us 2k squared plus 12k, so it gives us 2k squared plus 12k and minus 32 equals 0. And that's nice because if we divide through by 2, that factorizes. So just say what I'm doing, divide through by 2, that factorizes into k squared plus 6. Oops, that doesn't look like a 6, plus 6k and minus 16 equals 0. And that factorizes nicely because factors of 16 is 8 and 2. So I've got k plus k minus 2 and k plus 8. Yeah, that should be okay. So k minus 2 and k plus 8 is equal to 0. And, oh, I've shown that k is equal to 2. We're going to ignore the k is equal to minus 8 because it does say in the question show that k is equal to 2, and where k is a positive constant. So we don't want anything negative. So k is equal to 2, and that's the solution to part A. And I better write that down. So part A. Part B, it's saying determine, using k is equal to 2, so that means I'm going to substitute the value of k is equal to 2 now, in all three of the equations. Determine whether the three equations are consistent, justifying your answer. So let's extend the page and let's substitute the value of k is equal to 2 in all three equations. So I'm going to say what I'm doing to the examiner, telling the examiner that I'm going to subst k is equal to 2 in the three equations. Equations, and I just write ns like that. Equations. So I've got substitute, so 2x, because it's kx, 2x plus 3y is minus z is equal to 3, minus z is equal to 3, and then 3x minus y plus z is equal to minus 2, because k is 2, and again minus 16x minus 2y minus 2z is equal to 2. And yeah, these are my three equations, 1, 2, and number 3. Now, what I'm going to do is, now I'm going to almost like solve simultaneously. I'm going to add 1 plus 2, and the idea is if I get something which is consistent, that should be enough. So 2x plus 3, so add 1 to 2, I'm going to eliminate z. So if I eliminate z, so 2 plus 3x, that gives me 5x, and 3y plus minus y, that gives me plus 2y, minus z plus z, z's are eliminated, and 3 plus minus 2, that gives me, so 5x plus 2y is equal to 1. Now, if I multiply equation 2, so multiply equation 2 by 2, and then I multiply equation 1, apologies for that, multiply equation 1 by 2, not 2 by 2, multiply equation 1 by 2, what do I get? I get 4x plus 6y minus 2z is equal to 6. And then for equation 3, that's my new equation 1. And for equation 3, it stays the same. I've got minus 16x minus 2y minus 2z minus 2z again is equal to 2. So, and there's, oops, that's my equation 3. Oops, I need to make sure that's, yeah, my equation 3. My equation 3. And I need to say 2 times 1, so it's 2 times 1 by 1, and then take away equation 3. So 1 minus 3. So 1 minus 3, equation 1, take away equation 3, what does that give me? If it gives me the same as result as before, we've got some consistency. So we've got 4x minus 16x, that gives me 20x, and 6y minus 2y, that gives me plus 8y. Z's are eliminated, and that's equal to 6 take away 2, which is 4. Divide through by 4, that's nice, that gives me 5x plus 2y is equal to 1. And that's the same as what I had before. So therefore, I can say what the question is asking for, determine whether the three equations are consistent, justifying your answer. Do I need to do 2 and 3? If I do 2 and 3, I'm going to get the similar result. 5x plus 2y is equal to 1. I can, from here, should be enough for the 3 marks. Therefore, equations are consistent. Equations are consistent. I shouldn't have to overcook it by doing 2 and 3 or it's enough. Finally, part C, that's part B. Part B done for 3 marks. Part C for 1 mark. Interpret the answer to part B geometrically. Well, geometrically, there's always a consistent answer. Talking about consistency, part C, the planes form a sheaf. The planes, they're looking for this, form what is known as a sheaf. And that's it. The planes form a sheaf. And I believe that's the spelling. And that's it. Okay.